Welcome to Unit 10b. Unit 10b is all about how and why rocks break along faults and how exactly earthquakes occur and where they occur and why they occur. This set of videos is called Stress, Strain, and Faults, and it's going to be divided into two parts, 10b.1 and 10b.2. And at the end of 10b.2, we're going to come back to this set of questions that I have right here. So here's a photo of some beautiful mountains. And the questions I want you to think about are, what kind of stress creates plate boundaries with mountains? What kinds of faults would you expect in this region? And what kind of plate boundary most likely produced these mountains? And by the end of these two short videos, you should be able to answer these questions pretty easily. Here are the learning outcomes for Unit 10b, again focused on how rocks deform and earthquakes. These two videos will cover learning outcomes 7, 8, and 9. This first video will cover the three kinds of stress and then the three kinds of strain. So what is stress? Well, stress is a force, like gravity is a force, magnetism is a force, the dark side is a force. And in geology, we think of this force or these stresses as applied to rocks. Now, in this little cartoon here, there's sort of a misconception that if you squeeze coal really tightly, you'll get diamond. I think there was a Superman movie that promoted that idea. Not exactly how you get diamond. Okay, the three types of stress that we're going to look at are compressional stress, tensional stress, and shear stress. So we'll look at each of these. Starting with compression. So compression takes place when we squeeze an object. And shown here in blue is the object, we're just going to use a cube, before we have any stress applied to it. The stress is applied in the direction shown with the arrows, and afterwards we have a shape like the red box. So the blue is before and the red is after. In the real world, when we have compression, we wind up pushing rocks together and often make mountains in the middle. So the way this cube lengthens is similar to how mountains are uplifted. Another thing that happens when things are pushed together is they get folded. Just like this paper that I've got folded, right? It was out here and then I compressed it and now I have folds. Here's a pretty amazing picture of some folds in some mountains in Switzerland. There's two different colors of rock units that were initially horizontal, one on top of the other. There's some gray and some sort of orange color. And if we follow this orange bed down here at the lower left, we can see that it folds here tightly, and then it folds here, back, forth, back, all the way up to the top of the mountain. So it's kind of like our folded paper, but it's been turned on its side, like this. The second type of stress is tension. And that's when we pull things apart. So again, we have a blue box as our starting shape, and then the red box is what it looks like after the stresses have pulled in tension. In terms of rocks, we often get an area that is thinned, not thickened with mountains like the last example, but instead thinned. As you can see here, the red object is thinner than the original blue object. So horizontal tension can cause thinning. Sometimes we call this rifting. Now here's a very famous example of rifting. You might recognize this. We have California here. Then we have Nevada, which has been kind of stretched longitudinally a little bit more than what you would see on most maps. But all of these sort of north-south trending bumps are mountains. And in between all of them are basins. So if we go back to this picture, you're seeing the mountains and then the low basins, mountains, basins. This is a region that has experienced tension. Students always like to know where Las Vegas is because that's the one place they know about in Nevada. So I will show you, it's in the south part of the state in one of the big basins, right there. Here's a slightly different projection of that same area. You can see the extension is shown with the black arrows. And again, there is Vegas in one of the basins. Finally, the third type of stress is shear stress. And in shear stress, one surface slides past the other in the opposite direction. And so we end up getting a deformed shape. A cube is turned into a rhombohedron. One way to think about this is thinking about a deck of cards, right? If you have a deck of cards and down here there's a circle drawn on them, and then you kind of slide all the cards so that they're at an angle as shown here, that is shear stress. You held one side and you pushed the other side, and that circle has turned into an oval. Now, when it comes to rocks, shear stress produces long linear strike slip faults that are vertical. And so this is a good example of one, the San Andreas Fault, which we'll be talking about more. And the San Andreas Fault is created in a region of shear stress. Now you are in Los Angeles. The Mojave Desert, which we were just looking at, is on the other side of the San Andreas Fault. So in fact, the Mojave Desert is moving towards the southeast, and the Los Angeles area is moving to the northwest. Also, notice that shear stress does not thicken or thin the crust. Doesn't do either of those things. This is just an aerial photo of some mountains that have been offset along a strike slip fault by shear stress. So imagine you're a bird flying over this region pretty high up, and there's a fault that goes right through here, and this fault and these offsets have been created by shear stress. Okay, let's talk about the three kinds of strain. So what is strain? Well, strain, first of all, is caused by stress. So in geology, a force, a stress, causes strain in an object. And what is strain? Well, it's a change in the shape or the volume or the angular relations in an object. We think of the word strain when it comes to our bodies as maybe pulling a muscle. I guess that's kind of a little deforming of some part of your body. Here's a fossil up top called a trilobite, and this is in a rock, and it's a normal sedimentary rock that shows what a trilobite looked like. But down here we have a trilobite fossil that has been strained. It's no longer got this nice symmetric shape, and that's because it began to undergo the process of metamorphism, which starts to deform the shape of things. Strain by geologists is also called deformation. How is something deformed? And so the change in shape or volume is the result of the stress that we apply. So there's three kinds of strain, and I kind of prefer the word deformation. There's elastic deformation, ductile, or sometimes called plastic deformation, and brittle deformation. So let's look at each of these. Elastic deformation is when an object returns to its original shape after the stress is removed. So imagine pulling on a rubber band, and then you let go, you're not pulling, it's not under tension anymore, and it returns to its original shape. Another thing that you could think of in terms of something that behaves elastically is a bouncing ball. If you imagine a basketball bouncing on a basketball court, when that ball actually touches the floor, it does deform a little bit. It flattens on the bottom. But as soon as it bounces back up, the ball elastically returns to its original shape. Now, there's not a whole lot in earth science that behaves elastically, but there is something called the elastic rebound theory that we're going to talk about in a few more videos, and it actually explains the behavior of crust during earthquakes. So keep that in mind. A second type of deformation, the plastic or ductile one, does not return to its original shape after the stress is removed. The deformation is permanent. So you can imagine maybe if you know what silly putty is and you pull silly putty apart slowly, it is permanently deformed. If you let go, it's not going to bounce back like a rubber band would. Or maybe if you have chewing gum and you take the chewing gum out of your mouth, right? That's ductile. In geology, one of the things that you've already learned about is that the mantle, the astenospheric mantle, convects like a big pot of boiling water. And that convection is an example of ductile deformation. Metamorphic rocks also experience ductile deformation. As I was just showing you with the trilobite fossil, things are strained and change shape. Finally, the third one is probably the most obvious one. Brittle deformation is simply when an object breaks into two or more pieces. So if you drop a dish and it breaks, that's brittle deformation. Or if you snap a pencil in two, brittle deformation. In geology, importantly for our discussion, The motion along a fault, when rocks break and there's movement on either side, that is brittle deformation. Here's a little visual summary of these three kinds of strain. On the left, we have the plate before brittle deformation, and then it gets dropped, and then afterwards it's in two or more pieces. In the middle, we have some gooey dough that somebody puts their geology book on top of. I have no idea why. And that dough is now ductily deformed, and when we remove the book, it's not going to bounce back up into its original shape. Finally, elastic deformation is shown on the right. You guys probably remember these things called silly bands that you can stretch and put on your wrist, and they change shape, but once you take them off, they return to their original shape. To summarize, we have three kinds of stress: compression, tension, and shear, and three kinds of strain: elastic, ductile, and brittle. So pause the video and take a look at this rock. There's a penny down here for scale, and tell me what kind of stress you think produced these folds in this rock, and what kind of strain that represents. Compression, right? We're pushing things together, just like my paper, right? We're pushing things together and making them fold. And ductile or plastic deformation. We don't have things bouncing back, and we don't have things breaking into pieces. Next video will be the next 2 points in the outline.